My name is Claudia Reiter. I'm a PhD student at the University of Vienna, and I'm presenting you today part of my dissertation. Yeah, let's jump into it. Let's start with the research aim and introduction and a basic introduction to the topic. So as I'm a demographer by training, my presentation has very much a demographic approach, as you will see in a minute. So in traditional demography, it is common practice to sort populations along the dimensions of age and sex. And you've probably all seen population pyramids, which exactly depict this population structure by age and sex. And there is not much debate about this. So it makes sense to sort populations along these dimensions. More recently, it has become increasingly common to also add education dimension to these population distributions, and especially my institute at the University of Vienna, but this is also part of the Wittgenstein Center, which is a major demographic research center in Vienna, focusing on demography. We have a long history in adding education dimension to multidimensional demography and studying population distributions. But so far, the education in population distributions has been usually measured by highest level of educational attainment. So really focusing on formal education, which I here kind of classify as the quantity of education, as it is really looking at how many years did people study and what is their formal degree, while a quality element is completely disregarded. And I think this proves problematic for two main reasons. First of all, as you probably all know, attainment does not necessarily mean the acquisition of skills, and skills might be in many regards more important than just having a degree. And second, any changes in skills beyond the age when highest formal education is attained are not considered at all. So once you have received your highest formal degree, you will be in the population distribution, you will be shown with this degree, even though your skills might change over time. You will learn more skills, or you might lose skills because you get older. And this brings me directly to the research problem. So I think that the highest level of educational attainment alone cannot fully capture human capital as a relevant source of population heterogeneity. So what is the relevant source of population heterogeneity? I will come to that in a second. Before that, I will just tell you my research aims, which are twofold. First of all, I'm trying to incorporate a quality or skills dimension into existing population distributions by age, sex, and educational attainment. And second, I hope by doing so to improve actual comparability between the state of human capital in different populations and also subgroups of populations. And in this way, I want to answer the following research questions. Do literacy skills differ substantially between otherwise similar subpopulations and thus deserve to be considered a relevant source of population heterogeneity? Two comments here. First of all, as you can see, I'm focusing on literacy skills, and this is mostly because we have the highest data availability for literacy skills, but also I've done sensitivity analysis and my results are very similar. If for those countries where also other skill domains are available, I use numeracy skills, for example. And the second thing is, so what is a relevant source of population heterogeneity? And this brings me to my next point, which is really literacy skills as demographic dimension. So in a paper by Lutz and colleagues from 1998, the authors have defined 3 criteria governing the choice of dimensions in demographic analysis. And these 3 criteria are the following. First of all, the dimension needs to be interesting and therefore desirable as explicit output parameter. It needs to be a relevant source of heterogeneity with an impact on the overall population dynamics. And finally, the dimension must be feasible in terms of data and methodology to consider the dimension explicitly. And by using existing literature, I try to evaluate literacy skills in terms of these 3 criteria. And I don't want to go into detail here. You can read the fuller literature review in my paper, but just shortly summing up, in terms of the criterion 1, the relevance of skills, it has indeed been shown that skills matter equally or even more for many of the benefits of education, particularly in economic outcomes such as wages, employment and so on, but also for other social outcomes and development as a whole. So this criterion is kind of fulfilled. The second one, skills as a relevant source of demographic heterogeneity. And this basically means that it must have an impact on one of the main demographic changes, such as fertility, mortality, or migration. There's not so much literature on that, but still some studies have shown that literacy skills or skills in general may reinforce fertility effects of educational attainment and play a central role also in reducing mortality. So while formal education has been shown to be important to have an impact on fertility, particularly because of the networking effect, so just because you are in school, and this is particularly true for lower income countries, just because you're in school, this already decreases your likelihood of getting pregnant very, very early. But of course, if you have literacy skills in particular, this also increases your access to information, your planning horizon, and so on. And this in turn reinforces fertility effects, but also reduces mortality quite a lot. And finally, the last criterion, feasibility in terms of data availability. And this criterion was probably the main challenge, why not to include skills or quality adjustment before, because only since we have PIAG and similar studies, we actually can really internationally include skills to population distributions. So this has been only made possible by these recent initiatives. Okay, so far about that. Let's come to the data and methods. I mean, I don't think I have to talk about PIAG, you all know it. And as I said before, here will only show results from literacy. I've also included the STEP survey. I don't know if you're familiar with STEP, but if not, this was coordinated by the World Bank. STEP stands for Skills, Doubts, Employability, and Productivity. And it's also an adult skills test. It's targeted at low and middle income countries and also at the population aged 16 to 65, but only in urban regions. The nice thing about STEP is that it includes a literacy assessment, which is scored on the same scale as the OECD's PIAG. So it's kind of comparable, not completely, because they are only focusing on urban population, and there are a few other issues, but still I decided to include it in my analysis just to make the spectrum of countries broader. And I included 8 countries with STEP data, because only 8 countries conducted the full literacy assessment with the same 0 to 500 score scale as done in PIAG. And you can see the countries here: Armenia, Bolivia, Colombia, Georgia, Ghana, Kenya, Ukraine, and Vietnam. Okay, so those are all the countries that are included in my analysis. And the color here also represents the mean literacy score for kind of the working age population. So I summed it up for age 20 to 64. And you can already see quite some differences in terms of country differences, and particularly in the global south, literacy skills are much lower than in the global north. And finally, so this was all for the quality side of the education category, let's say it like that. But of course, I also need the quantity side. And for the population data by age, sex, and educational attainment, I used the Wittgenstein Center Data Explorer data, so data from my own institute. This is basically a very full data bank that first of all includes both reconstruction of populations by level of educational attainment going back until 1950 for 200 or more countries of the world, but it also includes different scenarios of future population and human capital trends until 2100. Here in this paper, I only focus on kind of the present data, so all set around 2015, but the plan is to maybe also project these skills-adjusted population distributions to the future. Yeah, as I said, there are 200 or more countries included, so all STEP and PIAG countries are included in the Wittgenstein Center Data Explorer data. And there are also a lot of other indicators in the data set, but I'm only focusing on population estimates here. The methodology is quite easy. So in multidimensional demographic analysis, actually population is divided into any number of states. So one state is age, one state is sex, one state is educational attainment, and then we want to add a further state, which in our case is literacy skills. But of course, since literacy skills are measured on a continuous scale, I have to somehow define a threshold. And I know that PIAAC has these very nice proficiency levels, but for my kind of analysis, they are far too detailed. So what I did, I defined the population-weighted OECD mean PIAAC literacy test score as kind of the benchmark threshold, but I didn't use the overall OECD mean, but I disaggregated it by age, sex, and educational attainment. So I calculated the mean PIAAC literacy test score for all OECD countries separately for these different age, sex, and education groups. And I think in this way, it is kind of a valid and accessible standard of comparison, even for countries which are very different in terms of age structure or educational attainment distribution. And by doing so, in the end, I was able to define 8, I call them here skills-adjusted educational attainment categories. So I start with 4 broad educational attainment categories, which are primary or less, lower secondary, upper secondary, post-secondary. And then each is further split into an above and below OECD average and skills category. Okay, let's come to some results. What you can see here is the density of literacy scores by educational attainment and country. So each of the 4 graphs represents one of the educational attainment category, and then each of the lines represents one country. And I have highlighted 4 countries just to show you the diversity and heterogeneity in literacy skills. And you can even see that, you can see quite clearly that people with the same educational attainment still have very, very different literacy skills, which supports my hypothesis that it's maybe not enough to just look at the formal education when we're doing population analysis. The difference is probably in the lowest educational attainment group, but this is also true because this is an open educational attainment category, so it includes everyone with primary education or less. And many people in Ghana that you can see here peaking at a very low literacy score, they probably never went to school. But basically you can find these differences in all educational attainment categories. And the dashed line here represents the OECD mean literacy score in the respective education category. Let's move on to the next result. Again, it's a density distribution of literacy scores here for South Korea. This time it's by age group. So I've used 10-year age groups here. And what you can see quite clearly is that every younger age group in South Korea has higher literacy skills than the older one. And this, of course, reflects both period and both age and cohort effects. So first of all, younger people might have higher skills because they are younger, they have higher brain capacity, and they haven't started losing skills yet. But also, of course, it's a cohort effect in a way that younger people are much better educated, especially in South Korea, which was the country with the fastest educational expansion in human history. You can see the same graph here for another country, for Kazakhstan. And what you can see, it's basically literacy score distribution is identical or more or less identical for all age groups. And this is very interesting because also Kazakhstan has had quite a significant educational expansion in the past. Not as much as South Korea, but still. But apparently the country didn't manage to translate its increase in educational attainment to a likewise rise in literacy skills. And finally, this is kind of the main output of my study, and I'm showing you here just 2 countries as an example, which are of course quite extreme countries and very, very different ones. You can see here population pyramids. So for those of you who are not familiar with population pyramids, you have the population size on the x-axis, the age groups on the y-axis. You can see that Ghana still has this very typical population pyramid shape with many, many young people, and the older the population, the less the population size. And then the colors represent the different educational attainment groups. So we have a dark red for primary or less, light red for lower secondary, bright blue for upper secondary, and finally dark blue for post-secondary. And again, you can see that the countries are quite different in terms of the educational attainment distribution. So Finland is much higher educated than Ghana. But in addition to those colors, I've also included this skills adjustment. So you can see each color is further split into an area which is striped and into an area which is filled. And everything that is filled means it is above the OECD average in skills in the respective age, sex, education group, whereas this striped area represents below OECD average in skills. And you can see that even those people in Ghana that are among the highest educated in the population, almost every one of them has literacy skills which are lower than the OECD average in this age, sex, education category, which gives them kind of a double disadvantage. Not only they are less educated, but even those who are higher educated do not have similar skills as in other countries. And kind of the opposite is true for Finland. And I've done this for all 45 countries in my analysis. And of course, you're welcome to look into the paper. So there are all the pyramids are in the appendix. But yeah, now I will just sum up with some concluding remarks. So my skills adjusted education pyramids reveal indeed empirical evidence for large heterogeneity in literacy skills among otherwise similar subpopulations. So I think this hypothesis was supported by my visual results that I showed you. Then I also found what I call inequality and quality, with poorer countries often experiencing this double burden of, on the one hand, people being less educated and also having lower literacy skills than people with the same education in other countries. I also found important inter-cohort changes in literacy skills, meaning that, as we've seen, for example, by the Kazakhstan graph, not all countries managed to expand the quantity of education and simultaneously experience a likewise rise in skills. And this could also indicate maybe for some countries kind of a quantity-quality trade-off, that they focusing so much on letting more people in the education system that maybe this has had impact on the quality side. And finally, I also think that my results partly challenge the optimistic view of recent progress in educational expansion. So if you think, for example, about the development goals, even though now with SDG 4, the goal is explicitly also mentions quality education, but still I think many of the indicators only consider, okay, how many people have some basic education completed, but it doesn't really consider how many people after they completed school have actually also good literacy skills or other skills. And yeah, so I think my results stress the importance of not losing sight on the quality of education. Okay, that's all from my side for now. I'm looking forward to your questions and comments. Thank you very much.